Yeah, I never did that.
I hit 110 this morning. I let off the gas.
How? I'm gonna buy it for college.
Here, Bob.
Alright, welcome back. Alright, today, all we're going to do is we're going to do a few notes, and then we're going to use some time where you can work on your assignment. Because I did give you an assignment yesterday, that page 79. Today's stuff is one of the last sections of the chapter P that we're in. So we should be probably expecting maybe a quiz next week at some point. We'll do our normal 2-day review kind of a thing. I know later this week we'll have certain classes are kind of messed up, so I'll try to keep everyone kind of on the same page because I know like period 9 won't get the same stuff you will. Like some of them don't have them every single day this week. So.
Here, any freshman or sophomore athletes that need to meet with her to report down to the locker room area at this time.
Okay, so let's go through just a few notes today. That's all I want to cover. I want to hit kind of the main topics what we're going to really discuss in depth tomorrow. Today is just kind of an intro, give you kind of a sense for where we're going with this stuff, what we're going to need, and then I'll kind of pick a couple examples from the book just to kind of show you kind of a type of problem we're going to be looking at, and then I'll give you some time where you can just kind of work on your assignment, page 79. So that's due what day this week? Thursday. So I do want to give you some time to work on it. I know it's only Tuesday, but it does take a while, especially that factoring stuff, with simplified fractions. So, all right. Today, what we're dealing with. P.7. We're dealing with equations. Okay, so let's talk about this. What is an equation?
As an equal sign.
As an equal sign. That's a big deal. That's the concept that we're dealing with now. I'm not dealing with expressions. Expressions very, very straightforward. You can simplify them only so far. There's certain rules we use for expressions. We use PEMDAS, the order of operations, right? Parentheses, exponents, multiply, divide, add, subtract. And then we had little quirky rules that we did when there's, fractions, we can multiply by denominators and all that good stuff. But equations are different. So what we're going to look at is how to solve equations. That's going to be a big idea. Because you can solve them. You can simplify expressions, but you solve equations for a certain variable. Or we can attempt to. Okay. Now the big idea here when we solve equations, the first type we're going to look at is a linear equation. Okay, we're not going to be graphing it. We're going to solve linear equation. What they mean by linear, it's got one variable. It's got one term we can solve for it. Eventually, what we're going to do is we're going to do with a multivariable equation. And I'll try to give you one of those, multivariable equation. And we're going to solve for one of the letters or variables on it.
Lacey Graham, please come to the office. Lacey Graham.
Now, they obviously, like these two bullets here are radically different. When you look at the problem, you can instantly see like there's just a different strategy when you do that. Now, when we get to multivariable equations, this will kind of branches because this will kind of give us a new set of tools when we look at those. Eventually, we will get into like the quadratics. So how would we solve something that has powers, like exponents on one of your variables? And we'll talk about there's a couple different strategies for quadratics. But this is kind of our goal. This is what I want to get to. Now, obviously, our goal today is just to intro this. So we'll do maybe just a few examples, maybe one of each type today, just so you can see this. And then I want to give you plenty of time where you can actually work today. And we'll try to do the same thing tomorrow, but tomorrow will be a little more in-depth. We'll try to go through the rules a little bit more, and we'll try to pick out the problems. Okay? All right, so does everyone feel comfortable with what we're going to talk about today? Understand kind of the goal where we're going? The reason why I bring this up, why I always do this section, obviously we've been learning, we've been reviewing the skills you should have learned in Algebra 2, or Algebra 1, or Geometry. where we've been at in chapter P. Expressions is a big deal to me. I understand, like, expressions, factoring, and doing those are skills we definitely need. Equations is another big topic. Like, this is just a skill we need to be able to solve for a variable, or be comfortable with, like, rearranging equations, because that's technically what we're doing on some of these. So that's what I want to talk about. All right, so I'm just going to pick an example out of the book, something that your book kind of shows as kind of a linear equation. So I'm going to just start with kind of a basic one. So here we go. Something like this. This right now, that problem is a single variable equation. Okay. Typically, it would be a linear equation. It's kind of the idea. And then if I didn't have the 30 there, it would actually be you could rewrite this into like slope-intercept form or standard form. But this type of problem is very easy to simplify. Right? The rules are that instead of going through the order of operations, we do what we call inverse operations. That's just how we do it. We do inverse operations. The inverses. Basically, what I remember about inverse operations, it's doing the order of operations backwards. So the acronym we use is this one. SADMAP. Yeah, I mean, that's just what it looks like. Right? So order of operations backwards. We add and subtract first. We multiply and divide, second. And we do exponents and parentheses last, if possible. Okay? But I mean, sometimes it's just going through this. We have to deal with things as we go. So, like for instance, on this problem, okay, when you do it, I mean, you can simplify this problem. Like I can simplify this side, I can simplify this side if there's a bunch of stuff going on. But the minute you want to solve for a variable, this is how you do it. You have to use this stuff. It's different than simplifying. It's when you're actually attempting to solve it. Okay? So it doesn't matter how you do this. Some people, like when they look at this problem, they like to simplify it first because they don't like the look of it. Then we solve later. It's up to you. What do you guys want to do? You want to simplify first, or you want to just go ahead and try to solve this?
Simplify.
What is SADMAP? Like,
SADMAP is when you actually choose to go ahead and try to solve what your x is right away.
Oh, yeah, do that one.
You want to do that, or do you want to simplify the problem so it doesn't look like it does now, so it's a little bit easier?
Just solve it.
Just solve it? Okay. Yeah, so it's just PEMDAS backwards. So if we're going to go ahead and we're going to try to solve for your variable, because there's two different strategies, and I'll show you both here. Okay, so if you're in this route where you just want to start here, we have to add and subtract first. So when you look at this problem, what number do we need to add and subtract first?
-11.
Yeah, you are technically subtracting 11 to both sides, right? Now I think of this differently. Oh, because I'm not that very analytical person. I'm visual. So what I see when I do this problem is I just drag the 11 across the equal sign, and it becomes the opposite. So it's becoming a -11, right, instead of a positive. It's the same thing, right? But technically what you're doing is you're subtracting these, which is the property of the opposite, and they cancel. So you're left with this. Right, and this over here was at a 19. Okay, makes sense so far? Now, that would be the first step, because you saw that we added and subtracted. Now we would attempt to multiply and divide, so I'm going to have to divide by the 5. Okay, so I'm going to divide by the 5 because that's the next rule. So dividing by 5, I'm going to divide both sides. It's the division property of equality, or quotient property of equality. The 5 would cancel here, and that's the multiplicative identity. That these would cancel. It's actually called the reciprocal rule. 5 divided by 5 is reciprocal. Cancels out to be 1. And we have 19 over 5, which is an ugly, ugly number. What is that? 3 and 4/5 as a fraction, as a mixed number. And then the last step. Now I can deal with the parentheses, right? Because we're down to the single parentheses. So how do I get rid of the 2? Subtract 2 across, right? So the 2's would cancel as property of opposites again. It makes 0. And then on this side, you could do, if you had a 3 and 4/5 idea, if that's what you change the 19/5 into, you can just take 3 and subtract 2 off. So and what you're doing is like if you're choosing to like distribute the 5, what you're actually doing is you're doing simplifying first. You're simplifying that problem down by doing the order of operations of parentheses distribution, and then you're going to move things around and move them across and stuff. So you did kind of the combination. This is actually like the way that I did it right here is the true inverse operation style, like going through every letter for letter, following the exact pattern, doing nothing out of the ordinary, not distributing, not doing anything, just following the pattern on how I need to solve it. Questions?
So do we have to use inverse operations for anything?
Just solving equations. If you're going to solve for a variable, you should be following those types of rules, so that you're not going out of order. Not like dividing the 5 over first. You might mess up because technically you're supposed to get rid of the 11 first. That's kind of for cool. Most people do that in their head. They just know the pattern how that's supposed to work. Me personally, I would have attempted this problem way different than this. I wouldn't have done it like that. Because that's not, when I look at that problem, that's not what I would have attempted to do. I would have, if I started this problem, and this is just a personal choice, it's up to you. This is how I would have done it. I would have distributed the 5 first. So 5x plus 10 plus 11 equals 30. I would have added these two together to make 21. And then I would have subtracted the 21 across, making 9, and then dividing the 5 over. Like, that's the way I would have done it, which is 1 and 4 fifths. Right? 5 fifths and 9 ones with 4 left over. So, that's what I would have done. It's the same process. Well, all I did was I just simplified first, right? I did the order of operations first. So I got rid of the parentheses and stuff. And I got it down to just a normal linear equation looking thing. And then what I did is I just did the inverse operations of the subtract, then divide. So that's the order you have to go in. You add and subtract first, then you can multiply and divide. I just like to get rid of all those crazy parentheses and stuff like that first. This is actually where mixed numbers come from. A lot of people always forget that. Mixed numbers come from actual improper fractions. So when you have that 9 divided by 5, what you're actually doing is you're doing this, 9 divided by 5. So this is your dividend. This is the divisor. Those are the terms we use for numerator and denominator. And the idea is that you put the 9 in the house, 5 on the outside, right? So 9 gets there first, dividend. 5 goes into that once. So 5 and 1 is 5. You subtract, you get 4. And this is your remainder, right? Well, that's how you make a mixed number. The remainder, right? Most people, elementary school, rate R4, right? That's your remainder. You just take the 4 and you put it over to what you divided by. So your 4 is your remainder, and you divide it by the 5. That's how you get mixed numbers. That's what they originally come from. But most people can do it in their head. Just figure out how many times can 5 go in. It goes in there once perfectly, and there's 4 left over. That's how you make your mixed numbers. Okay. What I'm betting is 100% of you are very comfortable with that problem. Because, that's what you've been taught for years. Since pre-algebra days. That's the type of problem that they just expect you to be able to solve at this point. It gets different when you see the other types. And this is where it gets tricky. This is where, I can't mentally prepare you for every problem, but I can at least give you strategies from how I would attempt them. Okay, so let's look at a different type, right? I'm going to leave this order of operations on the board, or the inverse operations, I should say. But now let's look at kind of a different problem completely. So instead of that linear equation, we're going to go to let's go to one of these. Now it doesn't look like the linear equation anymore, right? It's got fractions, got other things. It's still the same process. It's still the same work. You're doing inverse operations, you're solving it out, but now here's the thing. Well, most people, when they look at that problem, they're like, oh God, it's got variables in it. It's got other things. It's not a big deal. It's got multiple things. But what I would do on this problem, instead of going right to the order of operations, right to this and going add and subtracting first, you need to simplify it. That's the difference. When there's multiple variables, you should probably simplify. So So do the order of operations first, or do the rules we've learned over the last couple weeks. Then you can attempt to solve using these rules. So like when I look at that problem, my immediate instinct is get rid of those fractions. It's like 8 fractions. So I'll get rid of them. So the rule is, if you want to get rid of fractions, what did we just learn yesterday? What was the process for getting rid of fractions, like complex fractions? What do we multiply by? No, reciprocal. Yeah. You multiply by 1, which is the common denominator, right? So I'd be multiplying by the common denominator. You're allowed to do that on equations like this. When it has an equal sign, I can multiply everything by the common denominator. Well, what's the denominator between these two? 12. That's what I'm going to multiply by. And notice, I'm multiplying everything by 12. That is called the multiplicative property of equality, right? If you multiply everything by the same number, nothing's changing. Because I could divide 12 to everything, and all those 12s would go away. This is a balanced equation. If you do it to one side, you have to do it to the other. Notice, I multiplied everything by 12. Can't leave anything out. Because technically what I'm doing is I'm doing this, right? I'm doing 12 times the whole side, 12 times that whole side, and when you do that, you have to distribute the 12 to both. That's why it's written like this. That's what a lot of people always forget. Okay, so 12 times the top divided by the bottom. Well, here's the thing. Divide first. What do you get when you take 12 divided by 4? 3. So the 3 will be left over, and you take that times the top. That's my little shortcut for you. Instead of taking 12 times the top and dividing everything by 4 later. What's 12 divided by 3 here? 4, and then you take that times the top. I'm choosing to divide first. And now on this other side, I get 144. Okay. Any questions with how I just got rid of the fractions? Notice, you can only do that rule, what I'm showing you right there, if it's an equation. The rule we talked about yesterday on the complex is where I put like 1 over 1. Then I chose to like put 12 over 12. That's different because those are for complex. I'm multiplying the top off by the number 1. Here, I'm choosing to multiply the left and right side by the same number. That's a property of equality because it has an equal sign. Okay, now I can solve. I'll distribute, solve this thing out. So if I distribute correctly here, this turns out to be 3x plus 6. This turns out to be a 4x minus 4. And now you can solve this thing out and figure out what we get. Because what I'm choosing to do now is I'm choosing to actually simplify before I start. Because I don't like all these parentheses and all this weird stuff going on. So it looks like I have negative 1x, I have a positive 2, and a 144 on the other side. All right, do I need to go further, or do you understand like what I'm doing now? Notice, I'm simplifying it to what form am I at now? What form did I get to now in the black? What we just talked about a little bit ago. Linear. Got one single variable. Now it's easy. So that's like my little rule. You simplify problems until you get to a straight linear equation, and then you just do your inverse operations after that. It's the same rules. I'm going to add or subtract that 2 across. I'll divide it by the negative 1. That sort of thing. So I think the answer turns out to be what? Negative 142. I did it right? So you can actually solve. All right. Now those are linear equations, right? There's other types of equations other than multivariable, or there's other things. There's we have absolute value type problems, absolute value problems where we can solve for that. So let me just show you one of those. Let's say I had an absolute value problem, and it was 2 plus x minus 3 equals 10. This has still got a single variable, right? So on these problems, it's got a different strategy. What I need to do is I need to get the absolute value by itself. So I would move the 3 across. So I'm going to add this 3 over first because I need to just get this. It's like a parenthesis, right? You get the parenthesis by itself first. So I'll do this. I'm going to add that across. So I get 13. You're adding to this. Right? So now that the parenthesis by itself, now I can solve. And the strategy for when you do absolute values, and I think for sure that you guys definitely did this in Algebra 2. Definitely, because it was when you did, what do they call them? They called them, what's the term you guys use? Conjunctions and disjunctions. Oh, you guys remember that? This is a conjunction, right? How you solve this is it's an equal sign. There's 2 actual answers. Like this absolute value to make 13. What you just need to realize is what this actually number in here, whatever this thing turns out to be, could be a positive 13, right? Because if I take a 13 in here, what's the absolute value of 13? 13. Or this thing in here could turn out to be a negative 13. Because what's the absolute value of negative 13? 13. So there's definitely an or. So this is like a disjunction kind of thing. So there's two possible answers to this problem. Where this item could be equal to positive 13 on the inside. So because when you take the absolute value of it, it would give you 13 out. Or the original item could be equal to a negative 13. And you solve that. That's how you do absolute value problems. There's always two possible answers because the negative signs would cancel out. So you have to realize there's two potential answers to that problem. So you solve, so it looks like x could be an 11, or it could be a negative 15. So those are like the two numbers you could potentially use that would give you 13 plus. Okay. But again, it's a straight linear equation. It's just this is something that a lot of people never see. Like they just forget the little quirk you roll when you have absolute values. So there's two potential answers. That's the same thing if you did like square roots. Square roots are the ones we're going to look at tomorrow. But I mean, square roots have two potential answers: positive or negative. Positive or negative. That's a thing. All right. But we're going to look at quadratics probably tomorrow. I don't want to take any more of your time. So, all right, today, your goal today is to kind of work on page 79. Take your time, go through it. It's due Thursday, so I do want to, you can move around, you can work with partners. But I'll at least give you some time where you can actually work.
Do you have time tomorrow?
Yeah, you have a little bit of time. So my goal tomorrow is to like do this same thing. So. Because you're always paired.
Don't turn on.
Give up that.
Really? Oh, that makes me happy.
So for mine, I'm gonna turn my
Or
mouse.
am I just messing with
What page are you on?
I'm gonna put it be my mouse.
You had it on yesterday. You like it on? Right. Does you work here?
Who's making you nervous?
You want to go holiday decorating? You want to grab some stuff beforehand?
Oh, I have my problem.
I'll bring you over.
What is our athletic coach? Jamie? Jamie Smith. Is that what it is? I never know her name. She never knows.
Maddie and Aiden and Lacey are you like those? You like those ones? You like those?
I don't really need anybody except for
I talked to her about you last night.
What?
Yeah, it's like, and I asked she doesn't like it. Or I asked why she doesn't like you. Or why you don't like her. And
She doesn't like me. I don't.
yeah, and she was like, well, I don't like her, so kind of unusual not liking me. I was like, so I'm just moving. Okay.
She's the one that.
Have you ever started? Homework? Have you started? No. Okay, I do that one.
Oh, I forgot straight. Yeah, it's not really bad. It's just one of those grandfather. Hey, I'm driving you today. Because me and Bryce are going to go for something, and you and Seth are going to go for talking. It's really good.
Where you going? I'm gonna start doing big quotes.
I feel left out.
Yogurt?
That was a good question. What's the lowest amount of miles of parking you have? Oh, well, it's not that it's the lowest.
I want to shine. I know I can do it.
I've seen some get in the 300,000s, but I've never seen anything like 400. So I've never seen anything. Hold on.
I'm already.
That runs to the truck.
What the? 2,900,000 miles on a Volvo 1800 SQ we purchased back in 1966.
People will keep that money.
Yeah. Like, if I wanted to, I could easily just swap out my engine, get a brand new engine, put in my body, would have to go for 66,000 miles. Then I'll just swap out my body. Or I can save up 2,000 and get a Grand Prix GTP supercharged.
Let's get it out of your rate. Let's get it out of your rate.
I think the max I've gone was like 98. And then I stopped before my steering wheel started shaking.
Max up was But I had a truck.
Wait, what?
I'm right around. Too bad.
What did you say?
I have no inspiration. Usually when I
Oh, I haven't taught my I just stopped at 98, 99.
Let's see it.
Okay, I'm gonna test it out.
My Dodge your car today.
We're testing it out today.
Take back, what is it?
At Bryce's house, we're gonna test it out. Going 100 past Bryce's house.
As you're looking at No, see, I know yesterday was bad. Me and Brady passed back and he just asked me. But instead, someone kind of called me out being on track.
No, the high side. I was using on time, on Clear Lake. Oh, no. Interstate doesn't count. Okay, so it was Clear Lake started. I was like, I'd rather just get below so I have an excuse to do so. Be late.
The funny thing is, no one actually
I think I just get it.
Yeah.
No, I made it.
There's a lot of people that jump here.
It might be like maybe.
I know. You're really respectful. It's good.
I've
Like,
got
people
below
are starting to get back, like, with the 45-minute
It's
run,
just for this.
people are starting to get back more around, like,
That one that we were out.
Yeah.
After the music was too loud. I haven't gotten, oh, I finally put in a new light after a month
thinking,
of not having it.
oh,
Never got bored.
that's good, I saw it.
It's just weird things that never work.
A scrap piece of
You got, what is it? That's where we go.
At least 5 times. Twice that. Okay,
I
so.
got see, I was on that one day, and that's when the lyrics
Curfew.
started flowing.
Music.
And then I got unmad
I've gotten pulled
pretty
over
easily, and then I come again.
a couple times when I first
Maybe I'll
got
get
it,
mad.
they didn't have insurance, but those don't really count.
Maybe I'll write it. Just like that.
I had just first, yeah, so I had 30 days.
Yeah, I did not, but I didn't do a short rest, but. Just revise it.
See, I have mine on saved as well in my car.
I have some on book.
can do it.
Verbal charge.
You guys, it was like you and then
Not
me
how
and
about
Dan.
that, but
It can. It's not supposed to.
How you
That's
get
it.
there's no where you go.
See that part?
You guys said that you
One
were.
time I ran into a car and
Yeah.
I'm like,
He was going like
yep.
45.
And I was like,
You
car?
gotta keep
He's
going
like,
the
yep.
levels. You don't
I'm
wanna.
like,
As
what
long
do
as
we
it's.
do? And he's like, you call the cops. I'm like, I'm gonna call the cops on myself. He's like, yep.
When we had the windstorm back in the days,
Great.
you couldn't exactly tell.
That's when you look to see if
But I'm
there's
really
anything.
little.
Sure was.
There wasn't on the person's
Take a
car, but the
Snapchat
driver's
back
car.
42.
You're holding home in the night.
And
The driver's
it's
side.
like, if you let go of the wheel, it just immediately goes.
Yeah, so it's not his personal vehicle.
No.
But Derek said it was like $800 for what?
I went from, I was going like 8 miles an hour. Like, I mean, really,
I got my
or from the bridge. And I had like, probably 10.
One time I was like,
It was.
And I'm like bouncing.
I got
I got here, and I like bounced back on the road. I was like, I like threw